Good morning. It's great to be here. As Remy said, I'm going to talk some about accessibility today. It's not necessarily everyone's favorite subject, so I'm going to try and mix it up a little. Mix it up because I'm going to talk about accessibility mechanics, HTML, a bit about CSS, and also a quick look at some testing and other tools that you can use to help keep pace with accessibility as you're creating, developing products. Also mixing it up because I'm going to use one of my favorite tracks, a song called Technologic by Daft Punk from back quite some years ago now, which I think actually has some lyrics that sort of help me think about accessibility, and I hope they'll do the same for you. So let's get on with it.
Buy it, use it, break it, fix it.
So this is how a lot of people feel about accessibility, I think. Do we buy it in? Do we have the skills in-house? If I try it, am I going to break it? Probably. We break most stuff when we try doing it for the first time, but that's okay. Can we fix it? Yes, absolutely. And quite often, a big part of accessibility is having to fix stuff. We don't always have the luxury to get it right first time. We don't always have the luxury to start from scratch. Sometimes we just have to dive into existing legacy code.
Trash it, change it, melt, upgrade it.
So upgrade it. This is actually quite an interesting thing in terms of accessibility, because if you just use languages like HTML, you get a lot of accessibility for free. So most HTML elements have roles. If you use a P element, the browser knows it's a paragraph, usually of text. If you use one of the headings, the browser knows that it's a heading. And quite often, it'll take this information and do something visual with it. Sometimes it'll add functionality. But what it'll also do is provide some accessibility information about the element that's being used. So if you take a very straightforward link, just a very basic anchor with some text in the middle, and you were to look at it from an accessibility point of view, what you'd find under the hood is that the anchor element has a role of link. And it also has something called an accessible name. In this case, that's the link text inside the anchor element. And that's how an assistive technology like a screen reader that's used by someone who's blind will differentiate this particular link on screen from any other, in the same way that visually it's how you distinguish one link from another. And this is how a screen reader would announce this piece of code.
Tech.uk link.
So if we take another example, just a very straightforward image, this time it has a source attribute, of course, and an alt attribute. And we look at it from an accessibility point of view. We discover it has a role of image or graphic. That'll change depending on the platform you're using. It too has an accessible name. This time it comes courtesy of the alt attribute. And for a screen reader user, it's the alt attribute that describes the image, just a short description of the image. So it would sound something like this.
Graphic, a bottle of Chamuco's tequila with a dancing devil logo.
And the same thing happens if we look at interactive components like this just fairly straightforward checkbox. Input with a type of checkbox, it's in the checked state with the attribute, and it has a label provided with the label element and associated with the input. In accessibility terms, this has a role of checkbox because that's what the thing does. This time, the accessible name comes courtesy of the label element. And we also, this time, have some state information available. We know this thing can be focused on, and that currently it's in a checked state. And this is how a screen reader would announce it.
Tequila checkbox checked.
But there are a couple of elements that do not have very good accessible information available in the browser about them. They're pretty neutral, in other words. They are the div and span elements. And if you use these, there's no particular role that's conveyed to assistive technologies. There's no state. These things aren't focusable on. They're just completely inert elements. So anything you put inside a div or a span pretty much just appears as plain text and nothing more interesting. And that's worth remembering because we use these two elements a great deal as the building blocks for things like web components, custom elements, for custom widgets, and a number of different frameworks will also just use divs and spans to recreate existing HTML elements.
Chart it, point it, zoom it, press it.
So in terms of press it, what else do we get for free when we use HTML in the browser? The browser does quite a lot for us. It will make things focusable. We have a number of interactive elements in HTML, noticeably an anchor. When it has the href attribute, that's the thing that says if you use a keyboard, you can tab key onto this thing. It's also what makes the link interactive, of course. We have things like the button element, which too can be focused on with a keyboard. The browser just gives you that for free. And then, of course, all the form elements, checkboxes, radio buttons, text areas, and the like. And again, all we have to do is just use the HTML. We get the keyboard for free in this particular case. Sorry. It's all right, technology. You never want to work with a screen reader, trust me. Can I just borrow someone to come and help me look at this a second? I don't know, the screen reader stopped working, so I can't hear the slides. Does that do it? Yeah, got it. Awesome, thank you. So yeah, never mind working with children and animals, don't work with screen readers and projectors, the short answer. So when we use these focusable elements, these interactive elements in HTML, they appear in the DOM in the order we put them in the source code. That's pretty straightforward logic. What this means for keyboard users is that's the order that they access them in. So if you're using the tab key to move through a page from one focusable element to the next, you get them in the order they appear in the DOM. So if we have a quick look at this example, we've just got 3 really straightforward buttons. They're all focusable, 1, 2, and 3. And this is how a sighted keyboard user or any keyboard user would interact with them. So just exactly as it appeared in the code 1, 2, and 3. And again, this DOM order relationship with keyboard order is something that's really important, and we'll come back to that in a little bit. You also get expected interactions provided by the browser when you use these things. So when you use a link, it's expected, of course, you can click on it, but you can also use it with the Enter key if you're a keyboard user. You get that for free. If you use the button element, you can also activate it with the mouse and the Enter key, but also the expectation is that you can use the space key to activate something that looks like a button. And again, the browser will just provide all this for you, so you don't have to do it.
Snap it, work it, quick erase it.
So in terms of erasing it and thinking about it again, how does all this work in the browser itself? How does all this stuff come together to do all these good things? Well, if we go back and take that very simple HTML checkbox example again, very simple HTML code. What we know is that when you load that code into the browser creates the document object model, and it's this that we interact with in a whole bunch of different ways through scripting, user interaction. What you may not know is that the browser will also take some of the information from the DOM and create a secondary tree called the accessibility tree. It's related to the DOM, but it is completely separate. And the accessibility tree contains accessible information that assistive technologies like screen readers and speech recognition tools can query to find out what things on screen actually are. So all the information we saw about the image and the link and the checkbox earlier in terms of their roles, their accessible names, their states, all that information is available from the browser in its accessibility tree. So what happens is when we load some code in the browser creates the DOM. It then takes some information from that to create the accessibility tree. And when we manipulate the DOM, be it through scripting or user interaction, the DOM gets updated. That triggers an update to the accessibility tree. And that triggers a change event that assistive technologies can listen for. When they detect that a change event has been fired, they go looking for what has changed, they query the accessibility tree, and then convey that information to the user in whichever way is most useful. So, like the screen reader examples we heard before, they'll announce things to screen reader users in speech, for example. They do this by using something called platform accessibility APIs, and these are available at the operating system level on every platform, whether it's macOS or iOS, Android, Linux, Windows. They all have platform accessibility APIs. In fact, some of them, like Windows, have 2 or 3 different APIs. Unfortunately, these are not APIs that we can use as developers. They're strictly for use by applications like assistive technologies. The good news is that there is work beginning on something called the Accessible Object Model, which is a JavaScript API that will give us as developers access to the accessible tree in the browser. both in terms of being able to query it for information, but also in terms of being able to manipulate the information that's there. So that's pretty exciting work that's currently in incubation at W3 if you're interested in following that.
Write it, get it, paste it, save it.
So save it. I mentioned saving it, fixing it is a big part of what we need to do in accessibility. And there is a technology that comes in pretty useful for that. It's called ARIA, which is Accessible Rich Internet Applications. It's a whole bunch of attributes that you can add to HTML or SVG that let you add or change the semantic information, the accessible information that's available to assistive technologies. So it doesn't change the accessibility tree, but it does let you overwrite it. It's a very screen reader specific technology. It's great at doing what it does for screen readers, but it has a fairly limited application outside of that particular user group. So there are a number of roles in the ARIA specification. You use the role attribute with a value that will basically say, in the accessibility tree, treat this thing as a checkbox, a slider, a progress bar, a radio button, whatever it may be. You can provide the accessibility role for the benefit of assistive technologies. It also has some attributes for providing name and description. We looked at a couple of examples of things that had accessible names earlier in the slides. And the ARIA label and ARIA labeled by attributes let you provide accessible names for objects. If you need to provide a little bit more descriptive information, perhaps some formatting information on an input field where you need something to be entered in a particular format or style, you can use ARIA described by just to add an accessible description to a particular object. And these things are picked up by assistive technologies like screen readers and announced automatically when they encounter the particular object. And lastly, there's a whole bunch of states. A few of them include ARIA checked, ARIA pressed, ARIA expanded, and ARIA current. There are a few more besides this. And these can be used to indicate states. So if a button is pressed, you can use ARIA pressed. ARIA current is a reasonably new addition in ARIA 1.1, and that's for indicating something that's the current thing or the selected thing inside a set. So the most useful use case, I think, for it is for indicating the current link in a navigation block that says this particular link right now represents this particular page that you're actually on. It's something we've had a visual design pattern for as long as I can remember, but in terms of conveying that programmatically for someone who can't see the page, this attribute starts to fill in the gap.
Load it, check it, quick rewrite it.
So rewrite it. I'm going to take a quick look at a design pattern for a disclosure widget. If you want to go and see the finished article, it's available on that URL. And it's a worst-case scenario because we're going to start from some pretty rubbish HTML. It's going to start with a span for our control and a div for our content that's going to be shown or hidden. And you'll remember those things are completely inert in interaction and accessibility terms. So if we designed it, gave it some styles to make it look the part, this is the experience someone using a keyboard would have if they tried to interact with it in its current state. Absolutely nothing at all, because you can't focus on a span. It's not interactive, it's not focusable, and if you're a keyboard user and you can't focus on a thing to interact with it, that's pretty much game over, player one. So we need to fix it. We need to rewrite some stuff and start making things a bit better. And we start by making the control focusable. We actually use an HTML attribute, tab index, to do that. And if we give it a value of 0, that makes this span focusable at the point where the span fits into the DOM. So it slots it into the keyboard order in the kind of most natural way possible, or exactly as it would have done had we used one of HTML's natively interactive components. We're going to add a button role back into the ARIA using the role attribute with the value of button. In the accessibility tree, this will now say to assistive technologies, this thing is actually a button. In the DOM, it's still a span. It hasn't changed at all. The role attribute doesn't add any functionality. It simply changes the way this thing is presented to assistive technologies. But at least now, as a screen reader user, I know the thing I'm dealing with is a button, and that's going to set up certain expectations. We're going to add an ARIA expanded attribute onto the button control, and this is where we start adding in some of the state that visually on screen is pretty apparent. You can see when a disclosure widget is open or closed. If you're a screen reader user, you obviously can't do that. So we put the ARIA expanded attribute initially with a value of false because we'll start off with our disclosure widget closed down. And when a screen reader user now comes to that button, they'll be told that this thing is in a collapsed state. So again, it's setting up expectations. If something is a button and it's collapsed, you start to get the impression that if I hit this button, maybe something will expand or be revealed. We're going to add the ARIA controls attribute also once the disclosure widget has been opened. This is something of a controversial attribute. My friend and colleague at TPG, Hayden Pickering, has a great article on it because he feels that this attribute is not particularly useful. It's something we've had a good many conversations about over recent months, but it's a really good article to get a good look at it. What the attribute is supposed to do is set up a relationship between the button control and the content being manipulated. If you hit a button and you can see what's going on the page, you'll immediately see that some content has appeared, and you'll probably go and look at it, and that'll be all okay. As a screen reader user, if you come to this button, even though you know it's a button and you know something will be expanded, you don't know where that thing will be. It might be below the button, it might be above the button, it could be somewhere else entirely on the page. And you can actually spend an awful lot of time as a screen reader user hunting around trying to find the thing in question. So what ARIA controls does is hooks up the two things. So a screen reader user now coming to this button, opening the widget, should be given a shortcut that says, move my focus, move me to that content that has just changed. It all sounds remarkably good, and it would do if it wasn't for the fact that only one screen reader supports this. I happen to use that screen reader, so it's no wonder I think this is a really nice attribute. It is worth using it, though, because I'm hopeful that more screen readers and browsers will start supporting this particular attribute, and when it works, it's absolutely invaluable. We're going to add ARIA hidden. We had an extra span just tucked inside the button to contain a little visual icon to indicate the disclosed state of the widget. We've got the ARIA expanded attribute to do that for screen reader users. So for those of us who can't look at this particular widget, we don't really need to know about that particular bit of eye candy. So we're going to take it out of the accessibility tree altogether. ARIA hidden will leave it where it is in the DOM. It'll remain visual on the page, but it'll be taken out of the accessibility tree. So for a screen reader user, that little icon will just cease to exist. And then lastly, we're just going to use the hidden attribute, plain old HTML, to hide the disclosed content when the widget is shut down. We could use display none. That works equally effectively for both assistive technologies like screen readers and visually, of course, but hidden as an attribute is just as good. That's what we've gone for in this case. So we end up with some rendered code that looks like this. And the reason we've applied all of these accessibility bits and pieces using scripting is because if you don't have JavaScript available and you don't get the disclosure functionality, you don't really need to know that that control is a button. You don't need to know that the ARIA expanded attribute is in one state or another. You don't need all of that accessibility information because without the JavaScript, the content's just going to be non-functional and static and there for you to be displayed. So progressive enhancement in terms of accessibility is also a really kind of useful thing to think about. We're going to add in the mouse events, of course. We need this to work, so we're going to get it to work with a click. That's pretty much script 101, no problem. But we also need to do the same for keyboards because span has no inherent functionality of its own. You remember a bit earlier I said that if you see something that looks like a button, the keyboard expectation is that you can use it with either the space or the enter keys. So that's what we need to script here. So we listen out for the key codes 13 and 32 for those two particular keys. And if either is detected, we go ahead and initiate the functionality. And if not, we just let the keystrokes pass back through to do whatever it is they were intended to do. Lastly, we hook it all together with the actual meat of the thing. We make it all work. When someone opens the widget, we flip the ARIA expanded attribute over to true, and that changes the state. We add in the ARIA controls to hook up the relationship between the two programmatically, and hopefully everything starts to work a little bit better. So if you're a keyboard user, and specifically a screen reader user, this is the experience you get now we've done all that remedial work.
Tequila button collapsed. Enter. Tequila black up pointing triangle button. Use JAWS key plus Alt plus M to move to controlled element expanded. Move to controlled element. Makes me happy.
So suddenly there's a lot more information and, well, actually the thing works, so that's just a win all on its own. What you might have heard there, though, is that the little visual icon was announced by this particular screen reader. That's actually courtesy of a bug in Firefox, where if you put ARIA hidden on something that's inside a span, it ignores the ARIA attribute. Had we used a button element with the span and the ARIA hidden, it would have all worked tickety-boo. So hopefully that one will get fixed before too very long. But there's kind of another important message in all of this is that we could have done all this to fix it, and sometimes there are situations where we have to do all this extra work. But really, if you can just use HTML, you'll save yourself so much time and effort. If we'd used a button element instead of a span, we wouldn't have had to worry about the tab index, the role of button. We wouldn't have had to provide the JavaScript to provide the keyboard functionality because the browser would have just hooked it onto the mouse functionality. Even with a really simple example like this, it's something like 25% less code if we'd started off with HTML. Now, you can't really take sort of examples like this as kind of real-world applications, but it does make you think how much easier we can make it on ourselves as developers if we just start with some basic stuff in HTML.
Plug it, play it, burn it, rip it.
So in terms of playing it, ripping it, what do we do to kind of keep our accessibility kind of quality up as we are building and creating things, often when we're hurtling towards deadlines as well. And one of my favorite tools for doing this is developed by a friend and colleague of mine, Carl Groves, and it's an API tool called Tenon. And one of the reasons I like it is that it's just very lightweight, it's very practical. A lot of accessibility sometimes can feel very subjective, but hand-wavy, and it's certainly all that and more. But Tenon tries very, very hard to kind of make it as rational and logical as possible. So there are all sorts of modules pre-made for Tenon already, so if you're using something like Gulp, you can pretty much plug and play. There's a whole bunch of other bits and pieces besides. But because it's an API, of course, you can just weave it into your own build processes in whichever way you need to. It has a couple of basic required parameters. One is the thing you want to go and get evaluated, and the other is your key. Tenon is a paid-for product. It's not particularly expensive. The important thing to remember about the endpoint, the place you want to get something tested on, is that you point it to something in the browser. Because of all the accessibility mechanics that we looked at before, the way the browser, the DOM, the accessibility tree work together, it's really good to have your tool actually look at code once it's kind of been displayed in the browser and it's gone through all of those particular steps, because that's the accessibility experience that someone using an assistive technology is going to receive. So keeping it close to that is really a good idea. It also has some optional parameters that you can use. You can set a certainty level, so how certain is the API that the thing it's reporting is actually an issue, and it can do that on a percentage basis. You can choose the level of accessibility guidelines you want it to check. The web content accessibility guidelines are pretty much the generally agreed benchmark for testing accessibility, and there are 3 tiers, single A, double A, and triple A, so you can choose which one you want. Most people settle in on double A as kind of a practical, medium, and reasonably realistic kind of goal to achieve. Something else I really like about this tool is that you can also set viewport sizes. So if you're building something that's responsive, and most of us are these days, I think, you can actually get this to test it at its particular breakpoints as well. So if you're changing sort of things that have an impact on accessibility, it's really simple to test for those too.
Drag it, drop it, zip and zip it.
But it's just not always a question of having one tool or even necessarily just plugging an API like that into your own things. Often we're using kind of other frameworks, and it's useful to know what's out there for different tools. So Ember has an A11Y test suite. If you haven't come across A11Y, it's 11 is the number of characters between the A and Y of accessibility, so pretty much like I18N. Because we all got lazy and didn't want to type it anymore. These guys are actually doing a whole bunch of really good stuff around accessibility. So if you're using Ember, it's worth just pinging the Ember community out there, because there's some guys doing some really serious work to make Ember itself as accessible as possible. But this test suite will let you run individual or a suite of tests over what you're building, and it'll report back on things like, are roles applied, do things have accessible names, and a whole bunch of other useful things. React 2 has a test suite that you can use in pretty much the same way as the Ember one. You can run individual or group tests. React also has an accessibility API of its own, and there's a lot of information out this from the Facebook guys. You can actually use their accessibility API to add in things like role, accessible name, description, state, and lots of other useful information. So if you're building any kind of React application, it's worth checking out the accessibility API that they provide too. Angular is a little bit different. I don't know of any testing suites for it, unfortunately. One of the challenges with Angular is that often the thing you need to apply the accessibility to is buried so far in the code it's almost impossible to find. So the ng-ARIA module is actually quite useful because it will let you pretty easily drop ARIA, tab index, and a few other bits and pieces into your code where you need it. It's reasonably limited, but if you are building an Angular application, it's definitely worth checking this out because it can take a lot of the headache out of applying some accessibility where some doesn't really exist.
Lock it, fill it, call it, find it.
The other thing, strange as it may seem, that you can do is probably the least technical of all. You can actually just test it yourself. Unplug your mouse and see if the thing you're building works with a keyboard. You all have screen readers, whether you knew this or not. If you're using an iOS device, triple-click your home button to toggle the VoiceOver screen reader on or off. TalkBack has a screen reader too. Android has a TalkBack screen reader. If you're on Windows, post the anniversary update to Windows 10 in August, hit the Windows key and enter to turn narrator on or off. And on macOS, just hit Command F5 to toggle the screen reader on and off. Don't go making any huge decisions based on your experiences because you'll get lost and you'll get really confused, and that's okay. It takes a while to get used to using a screen reader if you absolutely have to. But just get a sense of how the thing you're building kind of sounds when you're listening to it and not looking at it. Or try zooming in on stuff. Pretty much all touch devices now have some kind of zoom enabled. Most desktops do as well. So just have a go and see what happens and get a sense of the experience of doing things without a mouse or without looking at a screen.
View it, code it, jump and lock it.
So, who remembers the film Space Jam from about 1996? Anybody? I'm guessing that somebody does out there. So, I said I was going to talk a bit about CSS, so this is not a sudden foray into movies, contrary to what you might be thinking. The reason I mention it is because the Space Jam website is still there. This is the website that was put up in, I think, about February or March 1996. It's 20 years old, and it's still out there. And it's got this lovely kind of like circular starfield pattern and all sorts of other bits and pieces. It's a total archaeology piece. It's absolutely amazing. And if you look under the hood, I don't know whether you'd be horrified or just amused, but this is what the code looks like. Everything was in the HTML. There was no CSS. There wasn't really much scripting at this point in use on the web. Everything was done in the HTML. So that was link colors, visited link colors, background colors, foreground colors, text colors. The whole 9 yards had to be put into the HTML. And this had to happen on every page. If you changed one kind of, slight thing in terms of your link color, you had to go and do that on every page of the website. And yeah, that was pretty horrendous. We also do formatting in the same way. Things like the center tag, the no break tag, or how we put things in the middle of the screen or in the middle of the containing element. We did things like tables for layout. Worse, we did fixed width tables for layout. Even worse, we did fixed width nested tables for layout. This is actually how they got that circular kind of starfield pattern thing, is by just nesting table cells, rows, more table cells, more tables, in some kind of just horrific tag soup, but that's how we used to do it. Even fonts were hard-coded into the HTML. We set the size and often the color in the HTML. And that was, a lot of coding.
Surf it, scroll it, pose it, click it.
But in terms of clicking it, well, that's pretty much all you were likely to be able to do, truthfully. You certainly couldn't have any style override. You got what you were given. There's no flexibility, so if you happened to be, say, partially sighted and looking at something on a low res on an enormous monitor, there's a really good chance that this design wouldn't fit properly. You'd either get huge amounts of white space or half of it would have disappeared off the side of the screen. There was really sort of very little freedom of choice or kind of personalization or flexibility at all in the accessibility. But a little bit later that year, December, along came CSS1, and we started that process of separating our design from our structure and HTML. It took a lot of the headache out of things. We could pretty much control all the basics of color, and including our link styles through a style sheet, and that made development a lot easier. And it started, or it was the origin of the ability to be able to override style sheets as users. Still not something, truthfully, that's done by very many people, but it did at least begin to enable that particular thing to be a possibility. So more upgraded, what happens now? CSS2 2.1 actually came along a couple of years later, and it introduced a lot more interesting bits and pieces. The one I want to look at most of all is the before and after pseudo-selectors, because they let us do some pretty useful and interesting things. And despite the fact that this is one of the older kind of selectors out there, it's still really commonly used. So if we take a really simple example, just a link that has its accessible name, its link text, and then we're going to use the CSS after to just slot in a little bit more information visually into that link. So we end up with some rendered code that in the HTML just contains that initial bit of link text and nothing else.
Name it, read it, tune it, print it.
So, print it. This is where it gets a bit interesting. This is what the spec says about generated content. Basically, if you add content using CSS, the CSS spec says it doesn't get as far as the DOM. It doesn't get processed by the browser, doesn't get passed. And so, bearing in mind everything we looked at before about the relationship between the DOM creating the accessibility tree in the browser, things are perhaps not looking good in terms of accessibility. Now, does anybody want to take a bet as to whether this screen reader is going to read just the link text or the link text with the after content? Okay.
Tab, tequila, makes me happy, link.
So, against all the odds, and certainly against all the spec advice, you actually get all the information, both the stuff in the DOM and the CSS-generated content. And the reason is basically that all the major browsers at the moment cheerfully ignore part of what the spec says. The content doesn't get as far as the DOM, and so therefore it doesn't get as far as the accessibility tree. But what all the browsers do is they just wedge that little bit of extra text information into something called the accessible name computation. We've heard about accessible names a number of times through this particular talk, and there's a whole algorithm that, if you're feeling really morbidly bored, you might want to go and read, but I just don't recommend it. It's the algorithm that browsers use to work out what the accessible name for an object should come from. And somewhere in the depths of that algorithm, it says that if there is CSS-generated content, add it to the existing accessible name. So in this case, we get both the link text and the generated content read by the screen reader. So it's happy, it's a win.
Scan it, send it, fax, rename it.
Rename it. Actually, not so much rename it, but reorder it. Coming forward now to current CSS, I know Rachel spoke about this earlier, the Flexbox is actually a brilliant advent to CSS. It means we can get rid of those float hacks for the first time in the better part of 20 years, and it makes stuff so much easier in terms of kind of visual design and layout. But there are a couple of accessibility problems, unfortunately. If we take our very simple DOM order example that we had before, just our 3 buttons, 1, 2, and 3, you'll remember that if you hit this as a keyboard user, you get them pretty much as you would expect. You get them 1, 2, and 3. So everything matches up. The order of the keyboard, the order that you see things on screen, it's all good. But then if we add in the flex, display flex, and we use the order to rearrange the buttons on screen so that visually they appear 3, 2, 1, we start getting some interesting problems for keyboard users. It goes in reverse order because, as a keyboard user, you're hitting things in DOM order, not flex order. And so we start getting this flex keyboard disconnect problem, where things don't really start to make sense in terms of the way someone who's using a keyboard interacts with
Touch it, bring it, pay it, watch it.
So watch it. It's all about this connection between the visual and the keyboard interaction. Here's what the spec says. If you're going to use Flexbox, don't use it for rearranging logical content. Just do it for the stuff that doesn't really matter so much. Brilliant on the one hand for them trying to at least advise everybody in the right direction, but really, come on. Flexbox is possibly one of the most useful things to come along in terms of visual design and layout, certainly, and suggesting that we don't all use it just because of this, I think is wishful thinking. Much as I would love everybody to just be able to do what we would like to happen in accessibility terms, we have to be practical when it comes to accessibility. So I think there is a conversation to be had about this. What are the potential solutions? We used the tab index attribute earlier to make something focusable where it wasn't. So can we use it in this particular example? This time, we would have to use a positive integer value for tab index, and we'd do it so that the tab indexing matched the order value. So the tab index would say 1, 2, and 3 to match the visual order presented by Flexbox. This is what would happen for a keyboard user. So far, it actually seems like it might be a workable solution, but there is a problem. The problem is that when you start using positive numbers for tab index, you have to take ownership of the entire keyboard interaction for the application. In this little 1, 2, 3 example, it's fine because we want that button to be the first thing that gains focus in the sequence. But if we were to drop this into the middle of a complex web application interface, say, I don't know, an email application or something like that, that number 1 button would still be the first thing that a keyboard user would be able to focus on the page. Wouldn't matter how many other useful, focusable things like links or buttons or anything else there was above it on the page, that'd be the first place that their tab key took them to. And so unless you want to actually start controlling the entire keyboard sequence of an application, and I seriously don't recommend it, it'll hurt. It'll hurt you as developers, it'll hurt people who use keyboards. This, unfortunately, isn't a viable solution. So there's a quick rule of thumb. If you add something into the keyboard sequence using tab index 0, it's pretty good. It's a natural way to do it. You can also use tab index with -1. That takes something out of the keyboard sequence, so someone who's using a keyboard cannot focus on it. Use it wisely. But it also means you can still focus on it with your scripting, so that's quite a useful thing to bear in mind. But basically, the ultimate thing to remember is don't ever use a positive number value with a tab index. It's just really not a good idea. There's another possibility, an ARIA attribute called ARIA flow-to, and this sets up a navigation order that we can, again, use to mirror the order attribute property on screen. We can say, when you are focused on this element, this flows to the next element. So button 1 flows to button 2 flows to button 3, and so on. Here's how it would work with a screen reader.
3 button has flows to. 2 button has flows to. 1 button has flows to.
So it sort of works, but it sort of doesn't. And again, unfortunately, there are some problems. It adds a third navigation strategy. So we've actually just made things way more complicated as developers. We've got our actual DOM order for keyboard users, we've got our Flex order for sighted people, and now we've got an ARIA order for screen reader users. And that's just all a bit kind of too complicated. Also, there's a support problem in that ARIA Flow-to is more or less not supported by anything. I think there's a couple of browsers and maybe one screen reader that do it any kind of justice at all. So sadly, that doesn't look like a viable solution either. There is a little bit of light on the horizon, though. Firefox has a bug, and I say bug in inverted commas because I actually think it's a really good solution. They call it a bug because it does contravene the CSS spec. But what Firefox does is rearranges the tab sequence, the keyboard sequence, based on the Flex sequence. So this is what happens. And that's just with using that very first example. No tab index, no flows to. It's just the standard HTML with the CSS Flexbox put in place. Firefox has done all the heavy lifting for us. So as developers, we don't need to worry about it. As users, we kind of get it sorted out. Screen readers do just behave a little bit peculiarly in some instances, but from a purely keyboard interaction point of view, Firefox actually, I think, has a really good solution. So perhaps this is our kind of conversation starting point. Perhaps we need to get the browser vendors to look at this as a solution, maybe give us as developers ways to turn this feature on and off, say match the keyboard sequence to the Flex sequence or don't, because I think there are probably sometimes use cases where we don't want the two to match up, but it's a conversation starting point.
Turn it, leave it, stop, format it.
So burn it, leave it, whatever, format it. Where do you start? What do you think about accessibility? It can seem like a bit of a crazy thing to tackle. Sometimes it feels unfamiliar, sometimes it's just new stuff and you don't know where to go and you don't know what to, who to ask, what you can do to learn about new stuff. But that's okay because that's where we started off with everything we do in our day-to-day jobs. I wasn't born knowing how to write HTML or CSS or JavaScript, and neither were you guys. So the answers are out there, and we can definitely do this. And there's something just worth remembering, is that it doesn't have to be perfect. We just have to make it a little bit better than we did yesterday. And if you can kind of stick to that idea, I think we'll all be heading in the right direction. Go away today and just unplug your mouse and try it. If it doesn't work with a keyboard, then see what you can do to fix it. Try it with a screen reader. If stuff doesn't get announced in the way that you think kind of sounds vaguely sensible, go find some screen reader users and ask them what they think of it. But just try changing one little thing at a time. And you'll be surprised how many people will benefit when you just make one little thing a bit better. So, is it really the case? Technologic, is it an anthem for accessibility? Well, I'm going to spin the whole lot now, all the sound clips from top to bottom, and perhaps this is kind of an anthem for accessibility.
Buy it, use it, break it, fix it, trash it, change it, mail, upgrade it, charge it, point it, zoom it, press it, snap it, work it, quick erase it, write it, cut it, paste it, save it, load it, check it, quick rewrite it, plug it, play it, burn it, rip it, drag it, drop it, zip unzip it, lock it, fill it, call it, find it, view it, code it, jump and lock it, surf it, scroll it, pose it, click it, cross it, crack it, switch, update it, name it, read it, tune it, print it, scan it, send it, fax, rename it, touch it, bring it, pay it, watch it, turn it, leave it, stop, format it. Technologic. Technologic.
So whatever you do, just remember that we are all human after all. You're human as developers, you're not going to get it right all the time. We never do. This is the web, for one thing. The people we're trying to make things better for are human after all, and if we can do just one thing to make it a little bit better than we did yesterday, then I think we can call that a win, don't you? Thanks.